Hey guys, welcome to my basement. For the last part of the notes for 8.5, I needed more space and better handwriting, so we're going to use the chalkboard in my basement. So on your notes, I'm still following along with the notes, you have stuff for how to find the nth roots. So we have talked about how to multiply complex numbers in trig form, how to divide them, and how to raise them to powers. So that's what we've done so far. So now we want to take roots of those. Now, when we're finding roots, remember that if you have some sort of equation, no idea what it is, I'm just making this up. Okay, if you have some sort of equation like this, the fundamental theorem of algebra says that since this is a cube, this could have up to 3 roots. It actually does have 3 roots. Okay, now they might be imaginary, they may not all be real numbers, but a cubic equation has 3 roots to it. So what this does, erase that, we don't need that. This is giving us a formula for how to find all of the roots. Okay, so if you want to find the nth roots of any complex number, to find each of them, you take the nth root of r, and then you have cosine theta plus 2 pi k over n, and then sine is the same thing. And then k, that changes depending on which root we're talking about. So if we have a fourth root, we would start with z0, and then z1, z2, and z3. This is a lot easier when you just see a problem done. Okay, so don't panic. None of that made sense. You'll be fine. So number 8, we're going to find all of the fourth roots of 1 and represent them graphically. I'm going to do this problem in radians, and then we'll do the next one in degrees, because you can do both. So to do this, now clearly what they want is they want us to take the fourth root of 1, and if you were just doing that in an algebra class, you'd be like, oh, it's 1, done. Well, it's the fourth root, there should be 4 answers. When we talk about the complex number system, there's 4 answers to this. We only know one of them. Okay, so that's what we need to find out. Now, in order to do this, we need to be in our trig form. So what we have right now is, we'll just write it here, 1 plus 0i. Okay, we want to write that in trig form, so r cosine theta plus I sine theta. All right, so let's graph that real quick. We're 1 this direction and 0 up, so this is it. So to find r, remember r is just the square root of a squared plus b squared. So r is going to be 1. And the angle this is making, clearly that's 0. I almost wrote theta, didn't mean to. Okay, so that's what we have. And now what we want to do is we want to take the fourth root of that. Okay, so we're going to call this z, and we're trying to take the fourth root of this thing. Okay. All right, there are going to be 4 solutions. So let me write them down. I'm going to switch colors even. We'll see if you can see pink. There's going to be z0, z1, z2, and z3. You see all those? Good. Okay. All right, so to find z0, what we're going to do, we're going to start using this formula. It's the nth root of r. So we're doing the fourth root, and r is 1. And then cosine theta plus 2 pi k. So 2 pi, and then k is this number right here. Okay, so this is going to be 0 divided by n. N is 4, fourth root. Plus I sine of the same thing. Okay. So when we do that, clearly the fourth root of 1 is 1. And then here, that's just times 0, so we have theta over 4. Not theta, that was a, sorry, that was not theta, that was a 0. Theta is 0. So we have cosine 0 plus I sine 0. Okay. All right, let's take a look at z1. Okay, again, we're using that formula. So it's the fourth root of r, which is 1. And then cosine of theta. Theta is 0 in this problem. plus 2 pi k, we're on solution z1, so k is 1, divided by n. Okay. Now, what I often do is I leave that blank because it's going to be the same thing and it just saves me some writing time. Okay, so this is going to be 1. This is 0 plus 2 pi, so this is 2 pi over 4, which reduces to pi over 2. So cosine pi over 2 plus I sine pi over 2. Okay, there's our second solution. We're going to go to our next solution. Again, the fourth root of r, so the fourth root of 1. Cosine theta, our theta is 0, plus 2 pi times k. K in this one is 2 over n, which is 4. And then the sign's going to be the same thing, so sometimes I just don't write it, just to save myself some trouble. So we get 1 cosine of, this is going to be 4 pi divided by 4, so that's pi, plus I sine of pi. Okay, one more. Still the fourth root of r, so fourth root of 1. Cosine of theta, theta is 0, plus 2 pi times k, this time k is 3. Sine's going to be the same thing, I'm just not going to rewrite that whole mess. And that's going to give us 1, 0 plus 6 pi, so we have 6 pi over 4, so we're going to have cosine of 3 pi over 2 plus I sine 3 pi over 2. Okay, we're getting there. These are our 4 answers. These are fantastic answers. These are our answers in trig form. Okay, and notice there are 4 of them, just like we said there would be because it's fourth roots. Okay, now we can keep going and give our answers in standard form. All we have to do is evaluate what's there. So let's do that. The 1 on the outside is not going to matter. So the cosine of 0, think about your unit circle. Cosine of 0 is 1. Sine at 0 is 0. So that solution is actually the number 1. Here, we're going to evaluate that. Think about your unit circle. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So this answer is I. We're going to evaluate this one. Cosine of pi is negative 1. Sine of pi is 0. And the last one, cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. So negative I. So these are your answers in standard form. Standard form. Okay, so 4 answers in trig form. Those are the same 4 answers in standard form. Okay, the last thing that it asked us to do was to represent these graphically. We can represent them graphically from the standard form. That's usually the easiest. So create your coordinate plane. 1, that's a real number, so you're going 1 in the real direction, and there's no imaginary number, so that's it right there. I, there's no real number, and then you go up 1 in the imaginary direction, so there it is. Negative 1 is right here, and negative I is down here. Now, every time something kind of cool that happens with these is when you graph these, when you represent these graphically, they are all going to be on a circle of radius r. Remember, our radius is 1. And they're going to be evenly spaced around that circle. So there they are. Okay. In the next video, we'll do another example all the way through. Seeing these really, really does help.